Can you hear me? All right. My name is Brian Schiller. Welcome to Let's Build OAuth. The idea of this talk is that which I cannot create, I do not understand, which is a Richard Feynman quote. And what he's saying there is not that you have to build everything from scratch, but that if we develop ideas as if they were from scratch, even if we're really leaning on other people who have thought about these things beforehand, we can develop a greater understanding of them. So that's just like when you're learning calculus, you derive some of the rules. And if you ever forget them, theoretically, you could maybe derive them again. But who knows how much that actually happens. With OAuth, like, you probably still are going to need to look at the docs for OAuth. But what I'm hoping is that this talk will give you an opportunity to be like, refresh tokens, why do I need a refresh token? Or what's the difference between an access code and an authorization code? Like, why are there so many different strings that I have to keep track of? So there are a lot of really small diagrams in this talk, and I couldn't come up with a way to avoid that. So you have kind of two options. You can squint, three options we'll go with. You can squint, you can bring up the slides on your computer or a friend's computer if you don't have one with you, or you can just say, I'm just here for the talk, and I won't pay attention to the diagrams, and I think you'll still get plenty out of it. But putting the slides up online, this is kind of my cop-out, my way of saying, I couldn't think of a way to make the diagrams any smaller. So I hope you'll forgive that. So a little bit of vocabulary before we get too far into it. Authentication versus authorization. So authentication is saying, this is who I am. Authorization is, I am allowed to perform this action, see this data, whatever it is. So it's the difference between, authentication might be, I control this email address, whereas authorization might be, whoever controls this email address is allowed to push edits to this GitHub repository, or whatever it might be. Authentication versus authorization. Confusingly enough, the HTTP authorization header, it's really mostly used for authentication. So as if things weren't confusing enough already. Also, a little bit of history. I just think this stuff is interesting, and it's more fun to know about the context. OAuth 1.0 came out, and it was good, and it was secure. But it was kind of hard to implement. There were a lot of like secrets and signatures, and it was pretty strict. And a lot of people found it to be too confusing. So there was a working group that came together to make OAuth 2.0. And the companies involved in this working group were mostly companies that already had something kind of like OAuth that existed. And their goal was not to make a great protocol that was easy to follow. Their goal was to make a protocol that would accept what they had already built, basically to make the smallest changes to their existing infrastructure as possible. And so the OAuth protocol has all kinds of like holes where you would expect, like, how long should an access token be? When should it expire? Should it expire at all? And it makes no recommendations in these directions because all of these companies who were involved were more interested in being able to call whatever they had already built OAuth than in making a good OAuth. So this is the reason you'll sometimes see on documentation, we only support OAuth 1.0. 2.0 is not an improvement. I actually think 2.0 is pretty good. This talk is going to focus on 2.0 because it's more common and it is easier to use, even though it kind of fails to specify, for example, how long a client secret should be, or all kinds of other things that perhaps it should if it were going to be a more solid program. Yes, protocol.
When you're going through it, you just point out and be like, oh, this changed from OAuth 1.0 and the things that did change?
Yeah, so I'm not sure there's a good place for that, but I'll give a brief overview right now, if that works. OAuth 1.0, the biggest difference between OAuth 1.0 and OAuth 2.0, OAuth 1.0 used cryptographic signatures all over the place. So it was, if you were going to make a request, you would sign that request. If you've ever used like AWS's APIs, a lot of what they depend on is like you have some secret and you sign a request to say, this is really me making this request and I'm timestamping it, and then you send it off and they're able to validate that. OAuth 1.0, I think, was actually designed that it could be used with HTTP, like emphasis on the lack of S, so without even SSL, because the signatures were timestamped, and it was more relying on explicitly doing public key signatures or other types of signatures, like an HMAC or something like that. You'll notice I don't know as much about OAuth 1.0 as 2.0, but it was using the security was built into the protocol. With OAuth 2.0, if you're not using SSL, everything goes out the window. There are no guarantees it can make about security or anything like that. OAuth 2.0 depends really heavily on SSL, which I think is actually a pretty good choice. It's an application layer consideration, and we can trust that SSL is usually, I don't know. If SSL isn't trustworthy, then most of our business goes out the window. So I think that's a reasonable compromise. I hope that helps with the distinction. OAuth 1.0 in general is more strict and has a lot more signatures, cryptographic signatures. OAuth 2.0, no signatures, we're going to use SSL instead, and it's a lot more wishy-washy. I just love this quote. This is from Aaron Hammer. He says, "At this point, I can no longer be associated with the OAuth 2.0 standard." Now, okay, who cares what he thinks, except that's the creator of OAuth. So it devolved so far that eventually the creator of OAuth was like, this is my baby, but don't put my name on it. Okay, so OAuth is for authentication. So for example, you might have a login with Twitter button. It says, I am the owner of the @BGSchiller handle. And you can trust that because this is Twitter saying so. It's also for delegated authorization. I give permission for Hootsuite to post tweets on my behalf. So remember that authentication authorization thing. This is an additional step. We're delegating the authority to take some action, and we're giving it to some other program or website, usually program or website that we trust. So when I log into Hootsuite, for example, I'm saying, I trust this company enough that I don't think they're going to make bogus tweets promoting their brand or something. I think they're only going to tweet what I want them to, and so I'm willing to give them permission to create tweets on my behalf. All right, so cast of characters. I'm not sure how this is going to play. I haven't really play tested this, but at this point, I'd like to ask for 5 volunteers who will be compensated in the form of candy. The volunteers will need to be able to sit and stand, but no, there won't be standing for longer than 3 minutes at a time, just by show of hands. Or actually, just come on up if you're interested.
What kind of candy?
There's a variety. All right, 3. Really appreciate it. Thank you, Tyler. 4, and we need a 5th. All on this side. Okay, so everyone go ahead and, now that you're up here, I need an Alice. So Tyler, so you'll see, well, let's get you set up. So you can put this one on yourself. I'll get this set up for you.
I don't know how to put this.
We'll need a Travis CI.
Do I get the hair too?
You get the hair also, yeah.
Thank you.
Travis, it is. Let me see if this fits on you. It's a little bit adjustable. Good enough?
Here we go, good enough.
Okay. We will need a GitHub. All right? So the GitHub logo is an octocat, so we have some cat ears. And we also have a tentacle.
Oh, does that work?
So you'll just put that on your arm.
Okay.
Let's take what's next.
And the attacker. So I don't have a ski mask, but this is what I wear when I go skiing. So you'll just put that over. It's like a little scarf thing. And then here you go.
Oh, man, yeah.
You get, yeah, it'll be brief. Like I said, brief, no more than 3 minutes. And a Google. This kind of looks like the Google logo, right? These were mostly made out of things that were already at my house. Okay, so let's build OAuth from scratch. So you can go ahead and have a seat. I'll call you up in a second, and I'll give you better instructions then. I saved you some spots at the front. The simplest thing that is kind of like OAuth, right? You can use it for authentication and delegated authorization, is share your password, please. And who uses this? Mint uses this. When you connect Mint with a bank, the bank doesn't always want to offer you access to their customers' accounts. And so they don't want to set up OAuth or some other system that would work for authentication and delegated authorization. And so what Mint falls back to is using give us your bank password, which is, kind of a tough sell sometimes. Yelp circa 2008 used this. There's a blog from Coding Horror. What's that? John something. I forget his name. Where he rants about this, and I think they fixed it afterwards. So I couldn't find any other examples of people using this. There's some obvious drawbacks, right? There's benefits too, but let's talk about the drawbacks first. It's all or nothing. There's no way to say, I trust this website or group or person to read things on my profile. Like I'm going to give you read access, but I don't want you posting anything. Or maybe I'm willing to give you privileges to write tweets, but not privileges to follow or unfollow people. It's a tempting attack surface. Mint spends a lot of resources doing the best they can to protect their database of passwords, but it's kind of like one of the cardinal rules in web development is don't store passwords. Hash them and store them in an unrecoverable format. But Mint has to store them in a recoverable format. So there's blog posts you can find where they talk about their security measures that they take, and it's a totally separate database. And here is the short list of servers that have access to this database. But it's still, nonetheless, a tempting attack service. Passwords can change. A user might change their password just because they forgot it, not because they intended to lock out their Mint account. But they changed their password, and so Mint can no longer access their records, and it can be kind of a hairy, oh, I didn't actually intend for my bank information to stop syncing, but that's what happened. It encourages phishing attacks. This one is a little bit subtle, but I like to think that we are responsible for training users that the only safe place to type in your Facebook password is on Facebook. And if I start typing my Wells Fargo password on mint.com, but that's considered okay, we need to be consistent in the way we're presenting passwords because this stuff is already hard enough. But there are also benefits. It requires no coordination with the provider service. This is why Mint uses this when Bank of America or Wells Fargo or whoever won't give them access. It's because you don't have to talk to them. They can't, it's not easy for a provider to prevent you from doing this, and it requires no upfront coordination. There is no other strategy we're going to talk about that avoids the need for coordination. You're always going to have to coordinate with the provider. I don't know how to get around that. I think there's a couple people trying. It has a simple UI and mental model. Everyone who types in their bank password to mint.com understands what is going to happen. They understand how it works. They understand the risks, in my opinion. Maybe that's not so true. But it's pretty easy to understand, oh, if I give you my password, then you can log in as me. OAuth, it gets a little bit muddier. And so it's the responsibility of providers, if in a login with Twitter situation, it's the responsibility of Twitter to say, here are the abilities that someone will have if you click yes, I accept. So this brings us to personal access tokens, which is the next best thing, like better than give me your password, please, not quite to OAuth. Personal access tokens, I just mocked up a little UI of how it might look if someone was asking you to make a personal access token. So they might direct you to go to a specific URL, like this is if some code review tool, wow, that's not readable when I do that, asked you to connect to your GitHub. So you might say, visit this website where you can generate a token. Check these boxes because I'll need these scopes. Click generate token. Copy what comes out. Paste it in this box. Hit submit. Here is, in case you thought I was just making that up, here are the documentations for Homebrew telling you how to do exactly that. You'll notice there are 2 big steps and 7 sub-steps in each of those. So this is really not a feasible user experience. This is something I'm going to skip. It's like a little tool that uses personal access tokens that I wrote. Right, so it's a UX headache. Some benefits of this, they can be individually revoked. That wasn't true with the give me your password, please. But at this point, if I decide I still trust Twitter, but I no longer trust Facebook, you can individually revoke these tokens. You can limit scope. You can, at this point, only check the box for giving read access, but not check the box for giving write access. The drawbacks are it's a user experience headache. It still requires coordination with the provider service. Like I said, we're not going to get rid of that drawback. Who uses them? GitHub, Trello, Twitter all offer these. Twitter did until recently. They changed their API. I don't know if they still do. But they're mostly targeted at developers because I think we're the only ones willing to put up with that amount of user experience headache. OK, so now I'd like to call up to the stage Travis, Alice, and GitHub. So here is the user experience flow for personal access tokens. And what I'm going to ask you to do is, you don't have to, there's no lines, you don't have to speak, but just like kind of mime out what's going on. And here is a token. GitHub has it at the moment. And the first thing that happens is Travis tells Alice, please generate a GitHub personal access token with the repo scope. Here are your instructions. And you give her some instructions. Once you're done, please give it to us. So Alice understands the instructions. Alice decides that she trusts Travis CI with repo level scope. So she goes to GitHub and says, could you please make me a personal access token with repo scope?
Gladly.
So GitHub gives it back. Here you go. And then Alice hands that back to Travis. Here you go. OK, so information went. Alice had to approve the transaction. But the main flow of this was that information needed to go from GitHub, the provider service, to Travis CI, the requesting service. And this is kind of like a game of telephone. Like Travis asked Alice, here are some instructions. Go tell GitHub this, and then come back to me with the information they tell you. Well, why does Alice have to carry that message? Why can't tell him yourself? So Travis could tell GitHub, I need these scopes. GitHub could ask Alice, do you trust Travis CI with this amount of access? And then if they do, GitHub would give Travis CI back the token directly. When I say directly, the way we're actually going to accomplish this is with browser redirects. So it's still kind of going through Alice, but Alice, if she is a user just clicking the link, she doesn't have to like memorize the instructions, remember which boxes to click. We've like alleviated a lot of the user experience headache of this. So here's how this looks with redirects, with browser redirects. Travis says, please visit the, oh, would you hand the token back? We're going to reset. Travis says, please visit some big long URL. It's a little hard to tell, but the scope is included as part of that URL, as well as the redirect URI. So it's almost like Travis is packaging up that information. I was going to make a big envelope, but I ran out of time. But Travis is packaging up all of that information, handing it to Alice's browser. Alice's browser just kind of hands it straight onto GitHub. The browser goes there automatically. GitHub comes back and says to Alice, do you trust Travis CI with repo level scope? Cool. You give the thumbs up? All right. So then GitHub gives back, please visit travisci.org, and hands the token. And the token is again passed as part of a redirect URL. Yeah, so it's almost, I think that's actually the case, but it's almost like GitHub is giving the token straight to Alice. Or I'm sorry, straight to GitHub, straight to Travis. It's good you're here, you're going to keep me honest. So the browser again goes there automatically, and at this point Travis has the token. And now they can get to work. So that is the bones of OAuth. That's like the skeleton of OAuth. Everything from here on out is going to use this basic framework. You can go ahead and have a seat, thank you. Is going to use this basic framework, except we're going to identify places where this could be made more secure, where our attacker can come in and steal some information or do other nefarious things. And we're going to mitigate those. How am I doing on time? OK. We're going to mitigate those with improvements that are going to look a lot like complications. This diagram is going to get a lot bigger, unfortunately. OK, so vulnerabilities and mitigations. Attack! Hijack the request URI. So if the attacker could come back up. And I haven't thought this through exactly what you're going to do, so use your creativity. Travis comes along. Oh, we need Travis and Alice, and GitHub. Google, you're in one small scene at the end. I know it seems like for such a big company you would have a larger role, but just one scene at the end. Goes back to GitHub. Travis tells Alice, please visit the authorized URL. Here's the redirect. Malware on Alice's computer, probably like some browser extension, intercepts and alters the request. So before it gets to GitHub, the redirect URL is changed to attacker.biz, which is controlled by our attacker. GitHub sees this, but doesn't recognize it, and they're like, OK, well, do you trust Travis CI with repo scope? Something that we're missing here is I don't have like a client ID saying like, I am Travis CI requesting this. But do you trust Travis CI with repo scope? Alice says, yeah, I trust Travis. But when Alice says yes, GitHub gives her a redirect URL, sending her to attacker.biz with the token attached. The browser goes there automatically, and GitHub hands the token to the attacker, who's about to steal all your codes. OK, round of applause for these guys again. You can hold on to it for a sec. You earned it. So the mitigation for this is to pre-register with the provider. What a bummer. This is like the part of OAuth that everybody's like, oh, but how am I going to do local development? This is such a pain. So I'm not going to make everyone act out the whole thing. But the important thing that we've added is down here over on GitHub is GitHub considers, is travisci.org allowed? Is that one of the allowed redirect URIs for this client ID? So this additional checking is going to prevent the attacker from intercepting the token. We're not quite there yet. We're going to see another attack soon. But this is the reason for that kind of, I feel like this is the part of OAuth that gives everyone the most difficulty because it's like, oh, localhost isn't allowed, and they require port 80. And one recommendation I have, I didn't put this in the slides, but there's a tool called ngrok, N-G-R-O-K. And what it does is it makes like a reverse proxy. It's like a tunnel to your local host. And so if you can reserve an ngrok subdomain and mark that as one of your allowed trusted redirect URIs, only for like dev or something like that. And then you can have that loop back to your local host, and it like works pretty well, in my opinion. Yeah, happy to talk more about that in questions later. OK, so the next attack, steal the token from the URL. I'm not going to make you act this out, because it's mostly the same. But you can see, even if GitHub checks, is that an authorized redirect URI? At the point where the GitHub tells Alice's browser, please visit travisci.org, and here's a token, and the browser goes there automatically. Well, if Alice has malware running on her computer, like if there is a Chrome extension to give your cursor a funny shape or something like that. What are Chrome extensions that are used for malware? I don't have any, obviously. So if the malware is running there, it can just see the URL on its way to Travis. It doesn't have to hijack the redirect URI. It can just see the URL on its way to Alice. And so the mitigation for this is to make that token worthless. So we're not going to quite make the token worthless. We're going to make it worth less. And so instead of having an access code straight away, the provider service is going to give back a URL that includes only like what's called an authorization code. And this is the first of those, like, what's the difference between an authorization code and an access code? An authorization code usually expires very soon, can only be used once, and is not useful for any purpose beyond getting you an access code. And you're like, what's the point? The point is, in order to exchange an authorization code for an access code, you have to prove that you are the person who did the requesting in the first place. So this is where that client secret comes in. When you go to request from GitHub to exchange I know there's a lot of words here, to exchange an access token. OK, so let me zoom back out. The request comes back. Alice's browser goes to travisci.org with an authorization code. Travis says, I'm going to trade that code for an access token. When they go to do that, they have to pass along their client ID, the code that they just got back, but also the client secret. And so this client secret never touches Alice's browser, which is a dangerous place to be. Instead, it only lives on Travis's server, and it's encrypted over SSL on its way to GitHub. And so GitHub is going to check that before giving Travis back an access token. So what we've done is we've made that token worth less. The authorization code is not super useful to us because all it can do is be exchanged for an access token, and only if you know the client secret. Question?
That encrypted client secret does not go through the browser, even encrypted. It goes straight as a post to the server.
Right, so that's Travis talking directly to GitHub. Yeah, it kind of looks like it crosses the Alice line, but there's just, I wasn't going to make a big swoopy line. Yeah. Good. What other questions? It's a good place to pause. We got a lot of tokens in play. We've got, do you mind holding up the access token? That's the really important one. And then we've got an authorization code too, which is one-time use. We're feeling good? OK. OK, right. So here's the new part, is going to trade that code for an access token. Attack! Connect to an attacker's account. So here, I'm going to need, let's see, who's the cast of characters here? We need an attacker, Alice, and Travis CI, and Google, finally. Let's go ahead and, I'm just going to take this back for now. This is a different sort of attack. This is the hardest one for me to understand. And I think the reason is that it assumes that there's the requesting service, which has been like Travis CI the whole time, also might have important data. So when I'm writing an OAuth app, I kind of think of my data as like, well, everything important is on Twitter, or everything important is on GitHub servers, and I don't have anything important. Turns out that's not true always. So like if you are able to well, let's go through the attack, and then I'll talk more about it. So the attacker has some work to do beforehand. The attacker is going to go talk to Google. They're going to pretend that they're Travis CI and make like they clicked the login with Google button on Travis CI's website. So that takes them to sign in, OAuth. Google says, do you want to log in to Travis CI? The attacker says yes. Google says, please visit travisci.org, and here's your authorization code. Now, the attacker's walking over towards Travis CI because they're following Google's instructions, but actually, they're going to hold on to that URL and not give it straight to Travis CI. Instead, they don't have to follow instructions. They're the attacker. Instead, the attacker thinks to themselves, maybe I can get someone else to go there. So they send an email to Alice. You might be a winner. Click here now. Alice says, a winner, and clicks the link. Well, that link was the Travis CI link that was going to finish the OAuth dance to connect the attacker's Google account with whoever clicks the link's Travis CI account. Like, there's a lot of people in play here. It's really hard to keep track. So Alice goes to travisci.org with the access code, and Travis says, oh, a code. Looks like Alice is connecting her Google account, and finishes the OAuth dance, getting an access token and saying, this Google account is allowed to log into Alice's Travis CI account. And now the attacker says, aha, I can see Alice's Travis CI data. Thank you. Go ahead and take a seat. OK, so this one is way more complicated to think about. Partly it's because Google has shown up, and they weren't in play for the whole rest of the talk. But what's happening is that there is important data to be found on the requesting service. So the two halves of OAuth. The OAuth dance is whoever is like making the tokens, and then the requesting service is the role that like I feel like we usually play, because it's a minority of people who have built the OAuth provider system at Facebook or Twitter. It's a majority of us who have done like log in with Twitter, log in with Facebook, log in with Google. And so it is sometimes the case that, for example, Travis CI has important data that an attacker might want to access. And so if the attacker can trick some unsuspecting rube into connecting the attacker Google account with the rube's, Alice's, requesting account, then the attacker gets some new information out of this. Yes?
What Alice's browser has been tricked into saying is, I would like to sign in with the attacker's account.
Yes.
Okay.
Yeah,
So
Alice's browser.
The original Google account,
Mhm.
because Alice has said, give the attacker privilege, not technically give mine.
Right. So when Alice visits that link, what it's saying is, I am logged into Travis CI. I'd like you, Travis CI, to please exercise this access code and give the account access to my, like whoever holds that GitHub account shall be able to log into Travis as if they were me. And who holds that Google account is the attacker in this case. OK, so the mitigation for this is to ensure the logged in user is the originator of the request, which is a bit of a mouthful. This is one of the most like confusing and I would guess frequently misused pieces of OAuth. I think that because it's hard to understand why it's important, it's easy to just skip this part. A lot of OAuth providers make it optional. This is the state parameter. So this is the one I was in particular thinking of when I said that this diagram was real small. We can zoom in a bit. So Travis, when they create an authorized result, can say, here is a state parameter. And that parameter is totally opaque to the provider. GitHub, for example, does not know anything about it, does not care about it at all, and all they're going to do is hand it straight back as part of the, like alongside the code. This is why it's so frequently misused, is because it is totally optional for Travis to check that state parameter. They could use the same exact state value for every single request, and GitHub might notice, might not notice, but there's not a good way for the provider to enforce this. But if Travis makes a unique state value for every request, then when the request comes back with the code, they can say, did the logged in user recently start a request with this state value? And if they didn't, then I'm going to reject this. I'm going to say something went wrong, try again. We don't have to assume that there was an attacker. Maybe it just timed out, or maybe there was an error somewhere else. But we don't have to finish the OAuth dance if the logged in user might not have been the person who requested the state. So how do we make a good state value? It should identify the user. It should be timestamped to prevent a replay attack. Also, to prevent replay attacks, you might want to make it single use, but that's a little bit harder. Timestamped is usually good enough. As a bonus, if say you're doing login with Twitter and login with Google, then you can encode extra information here. The provider is just going to hand it back to you. But sometimes when, if you have multiple OAuth login stuff, sometimes it's useful to be this is a login with Twitter request. So when the request comes back, you know that you need to trade out that authorization code for an access code by talking to Twitter, not by talking to Google. So you can encode extra information there, which is kind of nice. It should be signed so that no one can just spoof these things. Use some different secret key. It doesn't have to be the same as your client key, because again, this is totally opaque to as far as GitHub is concerned. This is some code or pseudocode that I often use to make states. You're welcome to take it. You'll notice that what it has is a timestamp so that we can expire them after 5 minutes or so. It identifies the user ID who kicked off the OAuth dance. And it has that additional, if I'm supporting login with Twitter and login with GitHub, I've noted that down so that when I finally get the redirect back at the very end of the dance, I can be where was I? Who was I talking to? It's a useful place to put that information. And then sign it by doing an HMAP, or HMAC, a hash method authentication code. Don't quote me on that. I think that's what it stands for. But basically, it's a way of encoding this information so that it must have been someone who knew the secret key that made the token. And you can look up more about this. I stand behind this as a choice of state. If you make this as your state param and it doesn't work for you, I'm willing to have you yell at me afterwards. So that's how much I trust it. OK, finally, what I'm going to ask for is Google, you can continue to sit down. Everyone else, please stand up. What the attacker, not everyone in the audience, but just the cast members. What the attacker, we're going to go through the whole flow. And at each step where the attacker might have had an opportunity, they're going to be foiled. So GitHub is going to need both tokens. Remember, this is the goods. This is just an authorization code. Yeah. So Travis CI says, please visit github.com, blah, 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 authorize, scope is repo. Anyway, they give a big old redirect URL to Alice. Alice takes that. The attacker tries to overwrite it. But they know that if they were going to do that, the GitHub would just reject the request, because that's not an authorized request redirect URI for this client ID. So they give up and go back to plotting. Alice's browser goes to GitHub. GitHub accepts the request and says, is Travis CI an allowed redirect URI for client? So it was smart of the attacker not to try and mess with things at that point, because it wouldn't have worked. GitHub comes back and asks Alice, do you trust Travis CI with repo scope? It seems that she does. Yes. So GitHub gives Alice a authorization code. That's the gold one in your right hand. To give to GitHub as part of a redirect URL. So remember, Alice doesn't actually have to like know this or copy paste it. It's just a browser redirect. The browser goes there automatically. Travis takes this, looks at it, says, did the logged in user recently start a request with this state? And they did. So the attacker was foiled again before they even started. So Travis goes ahead and trades that code for an access token. And now Travis can get down to work. All right, thank you very much.